Hey everyone. Hey everyone. Just trying to set up a couple of things, hoping that everything gets set as per my requirements and I don't have to cancel the class. So the first thing I want to ask you is what do you see right now? What are you seeing on your screen right now? Hi everyone. Hi. OneNote. Perfect, perfect, perfect. Okay. Okay. And what do you see right now? Notebook. Okay. Are you still able to see OneNote properly? And are you able to see Jupyter Notebook code? Perfect. And okay, I think this should be good then. Change theme in OneNote. I think I am too new to OneNote to anything right now. But I think let's try with this setup for like couple of minutes. And if you're still struggling, then maybe we can figure out. White background. Uh, is okay. Okay. Yeah, yeah. Let me just try writing and let me know if this is a problem. Is this a problem? Yeah, yeah. When you'll get the notes, it will be fine. I think it will be fine. It will be a PDF. I think by default, since my laptop is in dark theme mode, it will just carry it like this only. So let's just start with it, and I think it should be okay. First, I'll just have to first even get habitual to this thing. I just figured out like before the class because last time, if you remember, the iPad was not working. Yesterday started working, and now again it's still creating some problems. All right, so are we good? I think I should just ask this question to myself today. Use thicker line. Sure, sure, sure. I think, yeah, cool. I think I'll ensure that. Okay, so just to give you a brief idea of what's gonna be the agenda for next couple of classes. So we have discussed. So we have discussed NumPy. We've discussed pandas. we've discussed matplotlib, and we've also provided you a handout to at least get to know Seaborn. All right. Yeah, so that's all what we've done until now. And these are basically, I would say, the starter of data science. All right. So these are not, this is not really data science, but toolkits which help you do things in data science. All right. Now, let's start building the background. All right. So for building the background, first we'll do probability. Second, we'll do stats. Here we'll do descriptive stats. Next, we'll do inferential stats. Is the writing problem? Is the writing problematic or good? Is it visible? Give me a thumbs up if it is okay. Perfect, perfect, perfect. Cool, cool, cool. All right. Next, we'll do basic distributions, basic probability distributions. We'll do some advanced probability distributions. We'll do hypothesis testing. We'll do something called statistical tests after hypothesis testing. We may briefly cover experimental design. Although we'll cover this topic later after we are done with machine learning, but we'll give a brief intro to this, right? And this is gonna give you a good background to learn to basically perform to do data science in a much better fashion. All right. Now, once we are geared with this, I think we'll come back here and we'll again do EDA 1, which is exploratory data analysis 1. Here we'll focus on univariate analysis. All right. We'll do EDA 2. Here the focus will be bivariate analysis. If you don't know these things, it's okay. I'm just telling it just to set an agenda for those who are willing to know what are our plans. Next, we'll do a lecture on feature engineering. All right. And finally, that is where we will be able to summarize. We'll have not a lecture maybe, but we'll probably summarize EDA and provide you some kind of framework which you can use to better perform EDA. All right. And then again, we'll deep down into mathematics to discuss linear algebra, 3 lectures, coordinate, 1 lecture, calculus, 1.5 lecture. Got it? So this is basically the plan. And as you can see, it always goes from first some toolkit, tools, then background, then we'll cover the actual content, and then further we'll go back to either tools or background. All right, we'll do a mix of tools and background. We'll again do some tools like OpenCV NLTK. So I'll say again tools, and then again we'll get into content. Why? So that it doesn't become a big pressure on you to just keep on learning new tools and tools. I mean, imagine, let's say I have spent 3 lectures on NumPy teaching you every function out there which is possible in NumPy to use. Would you be able to remember it? No, right? So the whole idea is we are trying to understand students' cognitive burden and how much they can assimilate. And we've tried dividing all the topics which requires a lot of remembering across multiple lectures so that it doesn't become very heavy to really absorb a lot of functions, absorb a lot of tools and technologies and concepts in one go. So this would be the entire structure of the data science module. And this is going to take easily 1.5 months before we start doing machine learning. But I think this would be very, very, very detailed. All right. Any questions? Very quick questions, 1 minute. Any questions? Yes, we will keep on revisiting a lot of topics. जैसे matplotlib में if you remember in matplotlib we did np.vectorize, right? We will keep on learning new functions from NumPy and pandas even in machine learning, even in neural networks. LA is linear algebra, calculus is coordinate, sorry, CO is coordinate, and CAL is calculus. A/B testing would be part of hypothesis testing and experimental design. When will we job ready? I think everything that we cover is really important for you to become really employable. But I think after 4 months, I can say you can start looking for jobs. That's all I can say. But everything that we plan to cover would be really important if you really want to, be the best. So I would suggest, even if you start applying for jobs and start interviewing, maybe wait till the last module that we cover to take a final decision which company do you want to switch. You may want to take decisions in a informed fashion. Business case projects, I think you would have already started working on business case projects, right? I don't know if it is what Netflix project or something with Aerofit. I think you must have already started. No, nothing is assigned to you yet. Netflix project must have been assigned to you already. Okay, I'll check. I think maybe then they'll just assign it today. I think Netflix, Aerofit, one of it might get assigned. Oh, today's Friday, right? I think they'll just assign it today. Yeah. Cool. I think this is good. So let's start with today's lecture. How do I scroll further? I guess I can't. Okay, I think let's manage with that. All right, so today's lecture is going to be on probability. First of all, who all were scared to learn probability or to do all those fancy Bayes theorem and independent events and disjoint events? Who all were scared? Say yes for those who were scared. Okay. So we have a lot of people who were scared, but we have a lot of people who were not so scared. Still confused. Okay. How many people were not scared? Very scared. How many people are not scared? Say yes. Okay. How many of you who has marked yes now want to get scared? How many of you want to get scared? Right. All right. No, of course, our ideology is to not scare of people and make things difficult. Of course, we'll try a little best to simplify things as much as they can be. All right. And I would try my level best to make things as conceptual and simplified as possible. But yes, for the enthusiast, I have something interesting ready for you as well. And for those who have not been scared at all yet, I think I would give you at least a food for thought. If you've not seen something like this, so I think everyone is gonna enjoy this class. By the way, just to ask, although I will do this problem later, but give me a thumbs up if any one of you know Monty Hall problem. Give me a thumbs up if any one of you knows Monty Hall problem. Okay. Interesting. Okay, I think then it might not be a lot of surprise for a certain set of people. No, I didn't know Monty Hall problem for the longest while, and I recently came across this, and I thought, this would be very interesting to cover in the class. All right. So without doing a lot of talking, let's talk about probability. All right. So first, let's imagine that you walk, just for this lecture, let's teleport you to maybe Las Vegas, LA. And let's imagine that you enter to a casino with your friend. All right. So you and your friend went to Las Vegas and enter into a casino. All right. And the first game that you play there is called Cups in Money. Oops. Money in Cups. All right. So let's talk about variant one here. Variant one says that there'll be two cups. All right. There'll be two cups. I hope I can just write somewhat well that you're able to understand. And there is price, or let's say diamond, in one of them. All right. There is variant 2, which has 100 cups. 100 cups. All right. And there is price in only one of them. So here also one of them, here also one of them. Now, which one would you like to play? Which game, which variant would you like to play? V1. Why? None. V1. Why? Higher probability. Now, what does that mean? What is meant by higher probability? What do we understand by when we say higher probability? What does that mean? So higher probability to me, it means a certain event is likely. How much? So how much certain event is likely is what is calculated by probability. What probability tells us, right? Now, what is event? All right. Now, if I have to describe event, I'll have to describe two more things. I'll talk about an experiment, and I'll talk about something called sample space, right? So what is probability? Probability tells us how a certain event, a desired event, is likely, how much likely it is. And to understand an event, we'll talk about experiment, sample space, and that's how we'd be able to understand both probability, event, experiment, and sample space. Okay. Now, what is experiment? Any experiment, anything which has, let's say, some outcome is an experiment. So you perform something, and if it has an outcome, it is an experiment that you're trying to do. All right. Now, experiment can be of two types. Either it can be deterministic, or it can be random. All right. So why I'm talking about all of this, don't worry. I think you all know probability, but I just want to structure all your thoughts, whatever you've learned until now, into how I would say a data scientist should think about probability. So an outcome can be deterministic. What do we mean by deterministic? That it will certainly have a deterministic result, right? Deterministic means it will certainly have some result that we are aware of. All right. There are many processes out of which we know that this will be a certain result. All right. So how many outcomes are possible? How many number of outcomes are possible here? One. All right. Now, random is what is interesting here. A random experiment is where there can be multiple outcomes. For example, throwing a die. All right. So if I throw a die, either 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, or 6 can come. Right. Now, this is a random experiment. Why? Because there can be possible multiple outcomes. In deterministic, it would be like we do this and we know that this will be an outcome. We know the input, we pass it to a machinery, and that's we get a certain output. All right. We'll talk about certain things later on which are deterministic in nature. So we have all our machine learning algorithms mostly, including neural network, that you guys would be most excited about. Those are deterministic. We'll talk about those things later. But here, when it comes to probability, random experiments are what we are interested in. Why? Because that is where we will talk about how likely certain event is. All right. Now we have learned experiment, and we are talking about outcome, that an experiment can have certain outcome, right? Now all the outcomes of an experiment makes what? A sample space. All right. What does it make? A sample space. All right. What we'll talk about deterministic things later on. It can be as simple as like whatever, like maybe if you switch on, let's say, a button, maybe the light will turn on, and it's deterministic. We know. What is random? Maybe Schrodinger's cat is random. No, random experiment is probably throwing a die. 1 2 3 4 6 1 2 3 4 5 6, we don't know what can come. And that's why we are interested in knowing how likely is, let's say, 1, how likely is 2, how likely is 3 4 5, or whatever. All right, I think these things should be, I'm just covering it to structure everything to your knowledge, but I think let's not spend a lot of time so that we can focus on interesting stuff later on. All right, so all the outcomes of an experiment would make what? A sample space. So what is the sample space for, let's say, throwing a die? It will be 1 2 3 4 5 and 6. What will be the sample space, let's say, for tossing a coin? It will be heads and tail. That would be what? A sample space. Now let's finally come to what is an event. Event is a subset of your sample space. All right. Now you, in a specific event, you might be interested in how many heads do you get, or what is the knowing what is the probability or how likely it is to get heads. You might be interested in knowing how likely it is to get an even number. So okay, we have a sample space, rolling a die, 1 2 3 4 5. All right, what is an event? One event can be, what is the probability of getting an even number? What is the probability? 2 4 and 6. All right, so I will say 3 by 6. All right, what is the probability of getting odd number? Again 3 by 6. What is the probability of getting, let's say, 2? It's 1 by 6. Now these are all what is called an event, right? 1 2 3 4 5 6 together make a sample space, and probably, let's say, if we are interested in getting an even number, so the event that the desired outcome is what will make an event. So here it will be 2 4 and 6. All right, so we have three things. We have an experiment. Anything which has let's say an outcome will be an experiment. It can be either deterministic or random. Here we are interested only in talking about random experiments. Why? Because that is how probability will come into picture. All right, now any experiment will have certain outcomes. All possible outcomes would make a sample space, and the event which we are interested in, or the desired outcome, is will be marked as an event, right? Is this clear? Give me a heads up. Give me a thumbs up if it is all clear. And we'll discuss about bigger beast today. So no more extra questions. We'll cover everything. If you have questions, we'll talk about those things. Otherwise, most likely this lecture will be comprehensive. So no necessity to talk, ask any extra questions. As for now, to start with. All right. So maybe let's finally come to the definition of probability. Actually, before even coming to the definition of probability, let me actually talk about one more game that so in this class we'll be playing a lot of games in the casino, by the way. That is how the whole business discussion would look like today. All right, so let's talk about another game that you would play in Las Vegas Casino, game 2. All right, and here we'll discuss something called a frequentist approach to probability. All right, now here let's say you basically roll a die. All right, and a die will of course show you a number, right? It will be either 1 2 3 4 5 6. Now you'll get, let's say, $10 when you get whatever you choose, right? So let's say if I choose 1, and on throwing my die, if I get 1, I will get $10. And if I don't throw 1, if I get something else, I don't get anything. All right. So what is the probability of me winning the game? What is the probability of me winning the game? 1 by 6. Okay. Now this, if I calculate, would be somewhat around 0.166. All right. This will be somewhat around 0.166. All right. Now let's think that if you want to understand this machinery a bit more and see if how this let's say game works, what happens is you basically start sitting there. All right. You are basically babysitting this whole process. You're babysitting this whole process, and you see some 100 people playing this game. All right. And what you notice is out of 100 people, 20 people got 1. All right. They got 1. All right. All right. Which means from this empirical experiment that you've performed, or the 100 times if you've seen this experiment happening, all right, what you saw is that 20% of the times people get 1, or I would say 0.2 would be the probability. Now 0.2 is not equal to 0.166. So can you guess what is happening here? So here, at least from our calculations, we saw that the winning probability is what? 0.166. But whereas your experiment, let's call it a simulation, your simulations tells you that 20 out of 100 people got what? Got 1. Whereas as per your expectation, 16 to 17 people, around 16 to 17 people should have gotten 1. All right. What is wrong here? Answers in the chat. Yeah. So the problematic thing here is something called sample size. So sample size is what? Whenever you perform an experiment, all right, how many times you perform that experiment or how many samples you have from that experiment. For example, you can talk about data. If you talk about number of rows, those are basically like your sample data points, right? Which is telling you more and more about the whole system, right? Now your sample size was 100 here, all right? And with 100, what you got is 20. Do you think increasing the sample size would make it 21? Let's say if I change the sample size to 1000, would it make 21, or would it make it, let's say, 80? What do you think? 18. Who all thinks that 21 can also be possible? Either. Okay. What is more possible? I mean, yes, of course, 21 is also possible, but what is more likely? Right. What if I actually make it 1 lakh? What do you think? Will it go more towards 18? Will it be closer to 17? Will it be closer to, let's say, 25? 17, right? So here I'm trying to make a point is that as when you increase your sample size, you start getting more and more close to what is your theoretical answer. All right. So theoretical answer told you that the probability of getting, let's say, 1 out of all these numbers was 0.166. So you did this experiment with 100. It could have been either 20, it could have been either 11 or whatever. As you increase to 1000, it will go closer to 0.166. As you increase it to 1 lakh, it will go closer to 0.166 more. It will become probably 17 or 16 point something. And as you keep on increasing and goes till infinity, this will become 0.166 exact. All right. So what is the frequentist approach to think about probability? They say that probability tells you that if you keep on performing a certain experiment infinity number of times, all right. Now infinity is not a specific number. It means is that it's if you perform a certain experiment enough number of times, it will start giving the chances this the occurrence of an event that you are interested in would start following this number that you calculate from the probability value. All right. Now that we understand this probability, the concept of probability and the frequentist approach of understanding probability, let's talk about the definition of probability and couple of laws which probability follows. All right. So let me take up more space here. Let me say probability is equal to number of desired outcomes, all right, and I would say total number of outcomes, total possible outcomes. All right, I think nothing new in here. You don't have to overthink about anything. We've been learning this for a while, so nothing new in here. I just wanted to before starting with this thing, because that's how we've been learning about probability all through our high school. I think teachers would start from giving this as a formula to always ratify to cram. I think I just wanted to talk about a little more event, experiment, and sample space. All right. But is this definition valid always? Is this definition valid always? No, this definition is only, I would say only, this definition is only valid when it is only valid when all the outcomes are equally likely. All right. Why this definition we've been working until now is possible because we've learned all the examples wherein things are equally likely, and we'll keep talking about those things as well later in the advanced stuff. We may come across certain things wherein the outcomes are not equally likely. We'll see that in machine learning. All right. But here, if you see 1, 2, 3, 4, 5, and 6, anything on a die is equally likely. All right. Anything, let's say on a fair coin. All right. I'm talking about fair stuff. All right. So here heads and toss are also equally likely. All right. Something like a matchstick. All right. If you see a matchstick looks like this. Do you think it would be equally probable to get any face if you just throw this matchstick box? Or do you think any face any face? So it has how many faces? 1, 2, 3, 4, and 5, 6. Right, 6 faces. Do you think all these 6 faces will have equal probability of appearing? No, right? So here we'll have to do something more interesting than doing this definition. But for most of the stuff that we'll talk about today, this definition would go. All right. Yes, it will be based on surface area. All right. So remember, I think this is like a trick question, which some people of course know. A lot of people don't know. You always have to say, if you're defining probability as number of desired outcomes divided by total number of possible outcomes, you have to say that it's only valid when all the outcomes are equally likely. All right. I think that's this is going to give you whoever the interviewer is, although the interviewer is not going to ask you unless and until they really want to check your fundamentals. But yeah, do remember that this is only possible when all the outcomes are equally likely. All right. All right. I think I'll just use a thicker, probably pencil. I don't know if it is visible or not properly. All right. So let's after this, let's talk about a little more theory about it, probability, just to like formally cover everything. So first thing, there are two laws of I would say two laws of probability. First law, I think everyone knows. So probability of any event would be what? In between 0 and 1. What does it mean to have 0 probability? It means it's not likely at all, no chance. 0 means what? No chance. What does it mean by 1? It means certainly this will be the case, right? And this will be the case is what? This case will be what? The deterministic case, right? So here the randomness moves away from the system. All right. Now, second thing, what is the sum of sample space of any experiment? So you have an experiment, all right, and you have a sample space. Sample space is what? All possible outcomes. Now, what is the sum of probability of all sample space? All the possible outcomes in a sample space. What is the sum of this? Correct, 1. So you have a sample space, you have all possible outcomes, and you have their uh, probabilities. If you sum them, all right, remember this thing is for sum, this would be equal to 1. So these are the two basic laws of probabilities, and I think pretty much everyone knows, so I don't have to, like, I am just covering out of formality, but I think everyone pretty much knows this. Okay, does anyone know how I can scroll more if I want to? Can anyone help me with this? I'm just finding it too irritating to sort of write uh, like in half the space or what I have. I'm just trying to figure out. This will give me a box. This is giving me a box. Enter with text A. Left upper corner, click a bottom and use enter. Okay, so I click a bottom, but this is giving me a box. I think this got a bit sorted. Oops. Okay, got it. Cool. So we learned probability, we learned experiment, we learned what is a sample space. We also learned what is an event, or we saw that probability, we learned the basic formula of probability, and we also saw that it's only valid when all the outcomes are equally likely. And finally, we also learned laws of probability, right? Okay, so now that we know, let's come back to our first game. Oops. I think as soon as I started writing, it came again. All right, I think no worries. I'll learn more about this thing. Okay. As soon as I'm pressing the pen, I think it's going back to like the same thing. Okay. Okay, so let's get back to game 1. What was the game 1? We had two variants. We had a V1 variant wherein we had 2 cups. All right. And we had variant 2, where we had 100 cups. All right. So let's calculate the probability of winning here. What is the probability of winning here? The probability of winning here is what? 0.5. all right? And what is the probability of winning here? Probability of winning here would be 1 by 100, correct? I don't think any doubt shouldn't be here. All right. So of course, clearly we can see that this has a better chances of winning. All right. Now it's very much probable that you would have picked this one, your friend would have picked this one, and your friend must have been very lucky to even won this game when he chose one with 100 cups. All right, which is very possible. Probability talks about chances, and we've discussed the frequentist approach of understanding probability. What does it mean? It says if you perform an experiment infinity number of times or many number of times, then the chances of then the percentage times certain outcome or certain event will happen would basically be given by the probability number. Any questions in here? Any questions until now? Good time to control. Good time to ask. Not. We'll talk about Nirmal. We'll talk about it when we do advanced stuff. Not today. Not a good point to discuss today. We'll have a lecture separately on Bayesian learning. We'll talk about frequentist versus Bayesian there. Yeah, deterministic approach means that we are aware that whatever the outcome will be. So when we say deterministic experiment, we know the outcome, and since we already know the outcome, the probability of that outcome would be what? Equal to 1, correct? Because there is no other possible outcome which is present, and that's why it's called deterministic, right? Yeah. Okay, so I think a good time to maybe do this activity, and let's maybe do some interesting activity to understand this this idea of frequentist Bayesian approach. So I'm gonna say I'm gonna discuss this with an example of heads and tails. All right. So we say that probability of getting a heads for a fair coin is what? 0.5, and probability of maybe getting a tail is also what? 0.5. All right, so let's prove that from a frequentist approach setting. All right, so for this, first I'm going to import a random module. We've learned random module and we'll use this. All right, so what I'm going to do here is I'm going to actually run this experiment for different number of trials and see how the probability if the probability reaches close to 0.5 or not. All right, so in first case, I'm going to run this experiment 5 times. Second case, I'm going to run this experiment for 10 times, then 100 times, then 1,000 times, then 10,000 times. Yes. And then I'm going to run it for probably, I don't know how many zeros are there. Whatever, like whatever number of times. All right. So let me run this. Let me take this in for loop. I'm going to say for I in this. All right. I'm not going to spend a lot of time in explaining. All right. So let me start with a variable called win. All right. And I'm going to assign 0 to it. All right. And as we keep on winning the game, our winning game is, let's say, heads in this case, and without losing any generality, we can do the same thing for tails as well, the same experiment. All right. So as we keep on getting heads, we'll keep on adding this counter win by 1. All right. Now I'm going to say number of games would be what? Number of games would be equal to I, correct? I number times is I'm going to play a game in certain case. All right. So I'm going to run another for loop. I'll say for, let's say, J in range of games. All right. So I'm playing this game of tossing heads and coins, heads or tails. What? Tossing a coin, games number of times, right? Games number of times would start with 5, then we'll do 8, then 100, then 1,000, 10,000, whatever. All right. And here I'm going to say random dot random. All right. So this function will give me a random integer between 0 and 1. All right. So it will give 0 or 1. So I can say maybe 1 is the success. All right. So I'm going to say win equals to win plus equals to this. All right. So as if it will give me 1, I will consider it as, let's say, a head appeared in the coin. All right. And it will randomly, uniformly, randomly output 0 or 1 in between. Right. And as when I get 1, this counter will get will have one more value added. All right. And finally, maybe I can, once this for loop is done for these many number of games, I can just calculate the probability. Let me just say f probability for probability using sample size equals to maybe games, number of games. I would say prob equals to, what would be the value? It will be what? It will be number of wins, right? The number of outcomes in our favor divided by total number of games that we play, right? And I'm going to run this for 5, then 10, then 100, 10,000 and 1 lakh, whatever. All right. So if I run this, if you see, for first case, just when the sample size is 1, it's no way close to 2, no way close to 0.5. All right. With 10, again, it's no way close to 5. With 100, 0.48, yes, somewhat closer. With 1000, 0.462, not again closer. All right. For 10,000, it became better, 4.4947, very close. And for this much, it's very, 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 very close. All right. Now I'm going to run this again for a bigger digit and see what we get here. Probably it's going to take us a lot of time to even run this, but probably this number should be very, very, very close to 0.5. All right. Any questions in here until we wait for our final result? Maybe I think I should have not given these many zeros here. Any questions? Yeah, we can do the same activity for rolling a die, Muthu, and you can just go back and perform that activity. I'm not gonna do it because we have a lot more interesting stuff to cover today. All right, looks like I've sort of taken a very big number, so maybe let me show it with a small number. Yeah, so it says 0.4999425, which is very close to 0.5, right? I think the whole idea is clear, and we just performed this small simulation to show the effect of sample size. All right, and let me just for your notes, let me just add these things. You have the answer with you. All right, so if this is clear, let's go ahead and maybe play the third game in Las Vegas in the casino. All right, so we come to our third game, which is playing with cards. All right, so we'll play with cards. And here, while playing with the cards, we learn concepts like joint probability. We'll discuss conditional probability. And we'll discuss something called marginal probability. Maybe marginal will come late. Okay, I think fine, it's okay. All right, so let's understand this third game. All right, here we'll play with cards, as I said, and as a contestant, as a player, you have to choose one of the possible categories. All right, so let's talk about what possible categories are that you can choose. So maybe you can choose a face card. All right, what does it mean? It essentially means you can either choose a J, a Q, a K, or an ace. All right. You can also choose maybe a color card. All right. So you can say that, okay, I'm going to choose maybe red. I'm going to choose maybe black. All right. You can do this. You can otherwise choose a number card. So you're going to say that I'm going to bet that the card which will be taken out from the deck will be a number card. All right. I hope I don't have to explain all of these. Then maybe you can bet on maybe something like, an odd number or an even number. All right. And that's all you can essentially choose from. All right. So our first game, let me just get some space. Okay, so you and your friend further decide to bet upon certain things. So let's say you bet that it will be a red card. All right. Your friend bets that maybe maybe an odd number. Okay. All right. So what do we find? We want to find when is the case, what is the probability of the case where both you and your friend will win. All right. So let's maybe mark this with A and let's mark this with B. All right. So what do we want to say? We want to say what is the probability for the case where both you and your friend will win. All right. So this is what we are looking for. Now this is actually called a joint probability. So we have two variables. We have A and B. All right. A and B. A tells the probability of you winning. All right. B tells the probability of your friend winning. All right. What we are interested in is looking for the probability of what are the cases, what is the probability that your friend and you both will win. All right. This is what we are interested in. Okay. So couple of questions very quickly. What is the experiment here? The experiment here would be what? Drawing a card from a deck. All right. This will be the experiment. What is the sample space? A sample space would be 52 cards, 52 possible cards which are present in a deck. All right. Now, what are the events? Now, there are two kinds of events here, as I mentioned, which is the desirable events. First, the card number is an odd card. All right. How many odd number of cards are present? How many odd number of cards are present in your deck? How many of odd card present in the deck? Okay, okay. Okay, maybe let's talk about the red one first. Let's go in the order. So okay, so red one. This is easy. How many red cards are present in a deck? How many red cards are present in a deck? 26. So we have 52 cards in a deck, and then half of them are red cards and half of them are black cards. All right. Now, out of those red cards, how many of them will be odd numbers? First, let's look at how many numbered cards would be there. So we'll have 20 numbered cards, right? So we'll have cards from 1 to 10. All right. For what? For diamonds. All right. And we'll have 1 to 10 cards for what? What is the other one? We have, I think, hearts. Yeah. Right. So we have 20 cards in total, which are numbered cards, and out of which we are looking for odd number of cards. So 5 odd number cards from here and 5 odd number cards from here. All right. Is this clear? So what is the probability that A also will win and B will also win? All right. So the probability of the possible wins is these 5 odd cards or these 5 odd cards, because they both are red in color, right? So I'm going to say 10 here, and I'm going to write what should be the denominator. What do you think? What should be the denominator? 52. Any doubts in here? So basically, what were the possibilities of the first use case? 26. All right. What is the probability of second use case? So second use case, what was what? 20 cards, 20 numbered cards, right? And out of how many of them are both red and odd? So we had our 10 cards which are both red and uh, uh, red and odd, right? Ace won't be considered as a face card. Ace is considered one. So ace is, I think, usually not considered a face card. At least, I mean, the answer that I have uh, developed for this answer, I've taken ace as a numbered card and not a face card. Did I? Okay, sorry. Oh, sorry. Okay. Sorry. Yeah, I keep also changing my decisions. Like I am also like a confused being here. Any questions in here? We're not casino ready yet. Navroop, why? No, I'm sure we've played with cards, we've played with die, we've played with a coin. I'm not sure if I've played with coin, but yes, I've played with cards, and I hope you all have. If you don't know counting of cards yet, I think we won't discuss anything uh, in detail. Ace is nothing. Ace is, you can just consider ace as one. All right. So you have one in your cards. So what number one to two? We don't have money for casino. Yeah, just then play with your friends or your cousins without money. I mean, that's how I play. Sometimes we bet for 50 rupees out of fun. And yeah, and then we just party finally with all that money, 1,000, 5,000, whatever rupees. Yeah. Yeah. I prefer playing 28, and I prefer playing judgments. Not too much poker, but yes, poker is also interesting. Teen Patti. No, I don't. I play judgments and I play 28. Chocolate. Okay. Bluff. Hmm. Right. Yeah, side money. All right, guys. I think any questions in here before we move to the next part? We've discussed joint probability, and we're yet to cover conditional probability and marginal probability. What are non-numbered cards? You have Jack, Queen, and King as not numbered cards, and these are basically face cards. They are called face cards. So you have what? You have Jack, Queen, and King. Jack, Queen, and King. These are considered face cards. Yeah, probability is about, like, that is how people started. Like the origin of probability is related to gambling. It is related to gambling. That's how people got interested. Okay, so let's talk about our second example. All right, so here, so here you basically are now interested knowing uh, what are your chances of your winning if, let's say, you go ahead with an even number. All right, now you want to understand what are the chances if you go ahead with an even number. All right, but let's make it a little more interesting. Now what happened this time is, somehow what you get to know is that the host is not gonna pick a face card. So I'll say not picking a face card. All right, what are face cards? As I mentioned, JQK. All right, now this time you are interested in probability of knowing. Oops. Okay, I think I'm gonna take some time to sort of get habitual to it. But until then, please manage with me patiently. Okay, so we are interested in knowing probability of even number, and right now what we've made this thing interesting, but because somehow you are aware that host is not gonna pick a face card for you. All right. Now there are two things happening here. First, you're getting to know that what's happening. First thing, you are getting to know that you. Does anyone have any idea how can I sort this problem out? I guess no. So first thing is, okay, I think I'll just write maybe larger. That's how I'll manage. What am I doing? Is whatever I'm writing, is it visible now? I don't know what's happening. Okay, cool. Okay, all right. So here we are surely aware that it's not going to be a face card. All right. And now I have to calculate the probability of getting an even number. All right. Any idea how can we go with this? Let me denote these things with two variables again. So let me say getting this probability of our interest, it's can we can mark it as with A. All right. So the event of not the probability, the event of getting an even number, let's mark it with A. The event for not getting a face card, let's mark this event with B. All right. What is the sample space here? First, let's talk about what is the experiment here. What is the experiment here? What is the experiment here? Again, picking. Okay. I think I'm now losing my mind. What is the experiment here? Experiment is picking a card. What is the sample space? Sample space is again the deck of 52 cards. What are the events here? Events, as I said, first thing is even number. So we have A. And then we have no face card. That's the event B. All right. Any doubts in here? Any doubts in here? Now, the probability that you are interested in calculating here is called a conditional probability. So how conditional probability written is A given B. All right. So you are interested in knowing the probability of A when you know that B has certainly happened. All right. So we are already aware that it's not going to be a face card. So how would the probability of A changes knowing certain truth? All right. So B is the truth. B is what we are aware. It's given that B is the truth. All right. So how will this change? All right. So let's talk about the formula first, and we'll get into details of why it is and so. So the formula for this would be P, A, and B. All right. This A can also be written as this intersection. All right. And then this is scaled with probability of P. All right. So what I'm trying to say here is that you calculate the probability of A and B. What is the probability? What does it mean to calculate the probability of A and B? All right. Or comma here. This means A event is also happening and B also is happening. A and B. All right, event A happened and event B happened. All right. And finally, what do? We basically scale it with probability of P. We'll see why do we do that. But any questions until now? I'm sure most of you would have learned this formula. So any questions? If there are any questions related to, like, knowing or not knowing the formula, any questions around that? Just trying to get more space. Anything? Will the sample space not be 40? The sample space will be 50, but it's a condition somehow you're aware. So you're putting up a condition, but it doesn't stop the sample space being 52. Yeah, we'll discuss the logical intuition of this formula. We'll discuss. But as for now, I just want you to be, like, sure of that you understand this formula and that you have learned this formula. Face cards are not drawn, but this is, let's say you're saying, let's say if the face cards, let's say that the face card is not drawn. So how would the probability change? But the sample space still remains the same. All cards are equally possible. We are not keeping out the face cards. What we are saying is, let's say somehow you're aware that the host is not gonna take out a face card. Or you can imagine, you can think of like this way. There is a host. Can I not write it here? There's a host, all right, who has a 52 cards or a deck, all right, and he's gonna take out one card, all right. And after taking out that card, this guy has not shown you the card, but he says that it's not a face card, all right. The guy tells you that it's not a face card, all right. So earlier, the probability of you, let's say, getting an even number would have been something, all right. How does that probability, let me call it A, how would that probability change if you are given that, if you're being told already that it's definitely not a face card? How would that probability change? Earlier, it would have been something. How would this change now? All right. So what we learned is this can be calculated as P A and B, which is probability of A and B, joint probability, right? We learned joint probability, and the joint probability is scaled by B, all right? This can be written as P A comma B as well, and divided by PB, all right? Let's answer this first, and we'll talk about the intuitive understanding as well, I promise. So first, P, A, and B, all right? What is the probability that I see not a face card and an even number? Even number is what we were looking for, right? All right. So how many even numbers are present, let's say, in one suit? 5, right? So we have 2, 4, 6, 8, and 10, correct? And this will be present for all the suits, right? What else is the suit? We have heart, and we have this, yeah, for all the 4 suits. So we have 20 such even numbers, all right, which is our favorable outcome, right? The event we are interested in, all right. So I'm going to say 20. And what was the sample space? Total sample space, it was 52, all right. Now let's divide this with probability of B. What is the B? B is the event of not getting a face card. All right. So what are the face cards? We have Jack, we have Queen, and we have King. And then we have this for 4 suits. All right. So 3 4s are 12. All right. So we have to discount 12 cards, 12 such cards. Remember, it was not a face card, right? Not a face card, right? So we have to discount 12 cards. So the favorable outcomes would be what? 40 here. All right. And again, what is the total sample space here? It's 52. So basically the answer is 20 by 40 or 0.5. All right. So the probability of getting an even number given that it's not a face card is 0.5. Otherwise, what was it earlier? Let me say 0.5. What was it? What would it would have been earlier? It would have been 20 by 52. What is 20 by 52? 20 by 52 is definitely lesser than 0.5, right? And it makes sense, right? Earlier it was 20 by 52, and now that I'm already told by host that it's definitely not a face card, of course the probability of chances of getting an even number increases, right? So the chances increased to 0.5. We'll discuss intuitively what it means, but can you just understand the formula and also understand intuitively that the probability is increasing here? Why? Because I'm told some information. Now that I am told some information, my beliefs, the probability of my event, which was getting an even number, has increased. I'm gonna unmute Pratik very quickly, and then I'm gonna intuitively help you understand this thing. I'm gonna draw some figure, so help you understand this very quickly. Yes, Pratik, please go ahead very quickly. We have a lot to cover today.
Yeah, hi Anand. Am I audible?
Yes, you are. Please go ahead.
Okay, so in the numerator, you are saying probability of A and B, right? So 20
Yes.
by 52 isn't that
20
just 20 divided by 52? Isn't that just the probability of getting the even number? How is that the probability of A and B? I think
I'm
it
not
should be
sure.
20 by 40 in the numerator, and
Okay.
in the denominator it should be 12 by 52.
20 by 40 in the numerator. Okay.
And
And
in the denominator we just have to write probability of B, so it should be 12 by 52.
no, I think, I mean, I understand probably what you might not be able to understand, but I am still trying to figure out why would you make the numerator 20 by 40? So 20 is
So
basically the probability of even numbers, right?
in numerator we should write probability of A multiplied
Huh.
by probability of B, right? Or no,
And why
actually
would you,
probability of
huh? Yeah.
so in the
How
numerator.
have you got 20 by 40?
So A and B both happening, right? So
Right.
since the face card is not drawn, there are only
Mhm.
40 possible outcomes, and out of which 20 are the favorable outcomes.
Mm. No, I think the way you are thinking about it is in a conditional format, that you are aware that face cards are not getting drawn, and then you are saying, what are my favorable outcomes? What I'm saying is, think about it together. This is happening and this is happening. Like, think about them together. Let me just erase it and let me try explaining it once again. Maybe if it can help. Let me try.
Okay.
Mm, I'm just having some struggle with this technology first. Let me give it a try once again. For the numerator part first. I think I should have taken a better example. That's what I feel right now. But let me still try explaining with this. What was someone saying? Control N. No, Control N is also not working. No. This has taken me to next notebook altogether. Okay, so first thing is getting an even number. The other thing is not getting a face card. Actually, let me draw something. Who was it? Prateek, right? Hello,
Yes, Anand. Yes, Anand.
am I audible?
Yes, Anand.
Yeah, probably my video is disabled because of the poor network, but I hope my screen is visible probably.
Yes, it's visible.
All right. So let me actually draw a couple of diagrams, all right, to help all of you understand what I'm trying to say. If that can help, maybe. Okay, so let's think about this big space. All right, this is the whole sample space. Okay, so we have what? 52 cards in here, right, Pratik? 52 cards in here, right?
Yes.
And let me draw this thing with a full Venn diagram and let me call it 52. Okay. Now let me draw two more points in here. Let me say this is red and this is maybe black. All right. So I don't have black here, so I'm just drawing it with blue. Uh, Here I'm just calling it red. Oops. Okay, I'm just. So here in this red, we have what? 26 cards, right?
Right.
Whereas here in, let's say, black, we again have 26 cards, right?
Yes, Anand.
Now, here we have, okay, we have 20 numbered cards and we have 6 face cards. Does this make sense?
Yes.
Within red, we have 20 face cards and 6 face cards.
So
20 numbered
my
cards.
doubt was only about the numerator part. Okay.
Let's
When you are
actually do
saying,
it. Let's do it methodically. Let me
okay,
finish off
okay,
this thing, and then maybe let's redo it, and probably if that can help you understand, we can get
okay,
back to
sure.
numerator later. Okay, but stay on the call. Maybe like to probably just answer. Okay, so here again, I can maybe say 20 numbered cards and 6 face cards. Okay,
Yes.
within this 20 numbered cards, I will say 10 odd numbers and 10 even numbers. Yeah.
Yeah.
And here again, I'll have what? Uh, 10 odd numbers and 10 even numbers. Correct?
Correct.
Uh, Let me minimize this and let me maybe make another diagram. So this time, maybe, okay, how do I zoom in now? let me make a similar diagram here. And again, maybe we have this, and maybe we have this red, and we have this blue. Is my text visible, by the way?
Yeah.
Okay.
So actually,
And
in the above diagram, also we can simply count the number of favorable outcomes and divide it by the total number of outcomes. So that will give
correct,
us
correct, correct, correct.
20 by 40 as the overall probability. So the answer is correct.
20 by.
Even numbers provided that no face cards are drawn. So
Mhm.
favorable outcomes are 20 and total outcomes are 40, which are allowed. So that is the overall conditional probability. I am getting the answer, but I'm not
Right,
able to
right.
understand the numerator part.
Which was what? Which was 20
By
by,
52.
right. Um,
So
let me
how
actually
is
finish.
this? Okay, sure.
Yeah, let me like, I'm just thinking if I can sort of explain this. Let me give it a try. So here, this space is all card possible. This space is no face card is possible. Okay. Now, in within this no card face possible, you have what? Red 20, and you have what? Black 20, right? And you will have again 10 odd and 10 even. Here you will have 10 odd and 10 even. Remember, the sample space for this one is no face card. Here it is all card,
Right,
right? Let's talk about another one where the sample space is even and no face card. Okay.
okay,
Here you'll have red uh, equals to 10, right?
right.
Uh, Wait.
Black also 10.
Black also, black also 10. So this was 10 and this was 10, right? So this is what my transition is. ये तो clear है, right?
Right,
This part is clear. Uh, Here, uh, even number and no face card. This is clear. Now, how can, with this diagram, we can explain? I'm just actually trying if I can do some better job
so
with these
I just
diagrams.
wanted you to explain the numerator part, the notation,
Mm-hmm.
uh, which is probability of A comma B divided. Yeah, so
Right.
probability, what exactly is probability of A comma B?
So probability of A comma B is a joint probability. It means A is happening and B is happening. All right. Where you are not, you're not being, you're not told that B has happened and now you tell me how the probability of A is getting affected. All right. So the outcome that you are interested in is not P of A given B. You are interested in knowing what is the probability of having such an event where A and B both are happening. All right. So what is the probability of what are the possible outcomes, total outcomes wherein this condition is true? What is the condition? That it's not a face card and it's an even number. So that will be what? 20, right?
Right.
Even and no face card, right? And then out of total sample space of 52 cards, right?
Okay.
The second probability is of PB. What is the PB? PB is the case where it's not a face card. All we care is all the
Okay.
event that we
So
are interested in
actually,
is
I got where I found where I got confused actually, because there is no intersection between even cards and face cards. So the
right, right,
probability of just getting the even cards is same as probability of getting even cards
correct,
and no face cards.
Correct, correct.
Right.
So
So
that's
there
why
is
I
no
was actually
intersection
saying
there.
that. Yeah, yeah. That's why I was actually saying when I started explaining, that I should have probably picked a better example to carry out this activity. But let me try probably explaining it with this as well.
Yeah, yeah, got it, got it.
Yeah. Right, right, right. But just to complete this discussion, probability of B is how many cards are of type not face. So these are what 40 cards, and out of how many total 52 cards. So that's
Right,
how we got 20 by 40, right? I think the
right,
way
got
you
it.
were saying was what 20
So
by
the
40, right?
numerator is also the probability of just getting an even number.
That's
That
correct.
is where I got
That's
confused
correct. That's
because
correct.
there was no intersection between the two. Okay, okay.
Correct, correct. Yeah, that's why I was thinking probably I should have taken a better example.
Okay, sure. Thanks a lot.
Yeah, thanks. But otherwise, for other students, is this maybe clear? Is this clear? I know this is not was not a best example, and we'll probably talk about some better examples further in further questions that we'll do. But at least is it clear? Sorry, A intersection B. Cool. Let me just see if I want to make any remark before we go ahead finally. Mm, No, so this is basically how intuitively how I think, uh, given this conditional probability is that first you actually put the condition on the sample space. So I've put the condition of no face card, and then out of that, I am interested in knowing even and no face card. So this is already done, and now I'm just interested in even numbers. All right. So this is the favorable outcomes, and this is the total outcome that I have. So again, it will be 20 by 40. As you can see, 20 are the favorable outcomes, and then there are like 40 numbers in total. All right. So 20 by 40 is the final answer. If you want to think about this intuitively, but if you don't want to think about intuitively, and if you remember this formula from your high school, then you just know that probability of the conditional probability P of A given B is what? P intersection A divided by PB. All right. I hope no questions in here anymore. We'll do something more interesting to sort of give you more feel of it. But is the idea clear? Cool. Perfect. All right. So let's do a little more practice here before we carry on further. Let me just try understanding how to. First get more space in here. Meanwhile, I'm just struggling with it. Can just someone check how to like easily scroll down in this notebook? Okay, so mm, let's think about two variable game again over here. So let's say that you basically survey some 500 strangers in London, and you basically ask about two things: what is their gender and what is their choice of sports. All right. So either a person, let's say, is a male, or let's say a female, and possibly the sports that they're interested is in football, rugby, or other. All right. Now, if I actually talk about the distribution I got, is we have 120, we have 75, we have 100, we have 25, we have 50, we have 130. And let me just scroll down. I am not able to scroll down. Okay, I think I did something wrong here and I have made this thing permanent. Guys, can we actually postpone this class to Monday? Can we do this class on Monday? Would that be okay? I'm just super frustrated. I sort of came across, somebody told me that notebook, this one notebook thing should work, and I checked it was working, and I never knew that I'm gonna struggle with this much. No, weekend, I'm not sure, might be possible. Do you think weekend, I think you'll have other classes, so let's not overburden you with more classes. I think let's try to schedule it on Monday, and I'll probably take someone's help to understand this OneNote thing. I've always been a Mac person, so I'm not sure why it is happening. Don't drag the slider, use the arrows at the bottom of the scroll bar instead to extend the empty space. Let me actually check what you're saying, Saurabh. But yeah, the class is sort of dismissed, and I'll let the team know that I'm not able to manage with the class. Sorry, guys. Sorry for wasting your time. We'll probably cover this in Monday. I'm just struggling a lot, and it's just taking out, like, deviating my mind totally. Yeah, let me just unmute you. Who was it? Those who want to ask questions can just stay, but we won't do anything new. Hello. Arjit, hi. I've unmuted you. Sriram, I'll unmute you later.
Hi, Anant. Can you hear me?
Hi. Yes.
Hey, Anant, I have a question regarding the numerator part in the joint probability thing.
Okay.
So, see, by definition, when we're doing A intersection B, we do a probability of A multiplied by probability of B, right? We separately calculate the probabilities and then kind of multiply to get the intersection.
Right.
So, in this case, event A is what? Even numbers, right?
Sorry, can you go ahead, please, once again? Sorry.
Yeah, just the last one. Yeah.
This one only.
This one. Yes.
Yeah.
So, event A in this case is even numbers, right? So even
yes.
So even numbers meaning we have 20 out divided by 52. That's probability of A, right?
Correct.
And event B is not a face card. So probability of B is 40 by 52.
40 by 52. Okay. Yeah.
Now, if we do an intersection, shouldn't it be 20 divided by 52 multiplied by 40 divided by 52? Instead of just having 20 divided by 52 as the numerator.
So you are talking about the case. It's a special case. Let me just write it. You're specifically talking about a special case wherein P of A comma B equals to P of A into P of B, right? You're talking about this, right? That if you have to calculate P of AB, you basically take PA and you multiply it with by PB, right? So
Right.
this is a specific case when in events A and B are independent, Arijit. Here, the
Right.
independent events are not independent, right? In what are independent events, we were to actually cover it. We would have covered it towards the later part in the lecture. But independent events are essentially the events which are not dependent on each other. So let's say the outcome of getting an A is not at all dependent on whether I'm getting B or not. Those are independent events, and you can apply that formula for independent events only.
Okay. So in this case, I mean, logically, how we are deriving A intersection B? I mean, so
So
because
okay,
we are doing
yeah,
a
yeah, yeah.
P divide, yeah.
Right. So let me just explain. Let me go down a bit. And so P of A means P of A, if I talk in English, it means all the possible number of outcomes where both A and B are happening. All right.
Right.
And then total number of outcomes. All right. So I have to, out of 52 cards, I have to consider all possible positive outcomes where which matches both the condition. What are the two conditions? It's even and not a face card. All right.
Right.
Now, by chance, as I said, whoever, like, I actually didn't create this script, and whoever just created the script didn't take the best example out here. So essentially, it happened by chance that any no face card can be even, right? So it automatically ended up we ended up calculating probability of A as 20 by 50, and that will basically be the probability of PA comma B as well, which is 20 by 52. But here I am saying, if you have to think it logically, what you have to think is you have numbers 1, 2, 3, 4, 5, 10, whatever. Then you have J, King, Q, whatever. And then you have these things with different suits, right? For every case, you have to see if it is an even number and not a face card. If yes, that is your a positive outcome of your interest. 2, consider 2. Is it an even number? Yes.
Yes.
Is it not a face card? Yes. So 2 is a positive outcome that you want to consider, your favorable outcome. Is 3 an even number? No. Is it not a face card? Yes. But are
Yes.
both the things there? No. So this is
No.
not this will be considered, right? Is 4 an even number? Yes. Is it not a face card? Yes. Also yes for both the things, which is like and, right? So this is a favorable outcome. Just this way, number of favorable outcomes should be what? 20, right? Out
Right.
of all 50. And then you have total number of outcomes, which is 52.
Okay.
It happens to be the case by chance that this example was so bad that if you even calculate the probability of just even numbers, that also comes out to be, let's say, 20 by 52. But whenever we want to calculate joint probability for any outcome, we'll see if both A and B are true for that case.
Okay. Okay, I got it. Yeah, so so in this case, we are basically trying to, I mean, we are not just doing an intersection, we have a scenario where B is basically dependent on A. I mean, ideally speaking, but because in this example, B by default is dependent on A, or B cannot, I mean, B sample space is by default A sample space. So that's why it's almost 1. So probability of B is kind of 1 multiplied by whatever is probability of A, which comes to 20 divided by 52.
Correct.
I
But
got
here,
it. I got it.
to like logically see, the way to think about it is that I have to consider out of all possible outcomes, I have to consider favorable outcomes. What are favorable outcomes for which A and B, both these conditions are true? Right?
Okay.
I mean, I'm accepting that it's a bad example, and I should probably, like, while preparing for the lecture, I would have just realized that, it might confuse people, so I might just change it. I didn't realize. I was rather like I got back actually, I was on off this week, and I got back from the vacation, and I just was figuring out this iPad thing. Didn't realize this example can probably confuse people. But yeah, for Monday class, I'll make sure that, just to revise this thing, I maybe I can probably come up with some better example which can help clearing out this thing.
Sure. So no, clear actually now, Anand. Thank you.
Cool.
Yeah.
Anyone
Okay.
who has who can help me with this notebook thing, I might want to take them on the stage as well. But first, Sriram, maybe. Hello.
Yeah, Anand, can you
Dilreet,
hear me?
yes. Yeah. Hi, Sriram. Dilreet, I'll put you on stage after this. Yes. Hi, Sriram.
Actually, I missed the first 1 hour of class, but I just wanted to like discuss one thing maybe which can simplify this a little bit. I don't know
Okay.
if you talked about the theorems of probability, especially the one
Sorry.
with the probability theorems, like uh, something to do with the
Probably
union and
parents.
intersection. Yeah. So
Got it.
something like probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Because using the
Got it.
theorem, it would be much easier to, I think,
Uh-huh.
approach this. Because in this
Got it.
case, in this
Mhm.
case, we are thinking of probability of A intersection B, right? So
Right.
you can write it as probability of A plus probability of
No, I
B minus,
actually got your point.
yeah.
Let me actually, you know what? Let me redo this maybe example, and maybe I can also count in your suggestion where I can probably talk about theorems
Sure.
of
The
probability,
probability. Yeah.
the
I
intersection
think
and the union one,
make it a little
right?
bit easier. If we go like this is kind of more algorithmic approach. I know you're trying to explain intuitively, and some people may have trouble
Yeah. I
understanding.
mean, like, I'm not a big fan of talking really things from formula, and maybe that is
Yeah,
why we
yeah.
would have.
No, I
But
totally
yeah, like
agree.
that
So,
can probably help then hurt,
yeah,
so
yeah.
we might want to use it rather.
Yeah.
Cool. But
And the
thanks for
thing is, since you're doing both intuitive as well as if you do it through formula, I think maybe it will be somewhat clear
correct,
to more people. So I just want to
correct.
bring up
No,
that. Yeah,
I
that's
think probably the culprit was a bad example.
yeah. Maybe
Otherwise, it
just
would have been
maybe
okay.
like a simpler example to start with may
Correct.
have
Yes,
been
yes.
more helpful. Yeah, that's it, Anand. Thank you.
Got it. All right. Okay. Thanks a lot, Shriram. Thanks. All right. Thanks. Yes, Dilreet. Dilreet, can you raise your hand so that I can just probably unmute you very quickly? Yes.
Hello.
Manish, yes, the class is dismissed, so we are just like, I'm taking up questions and I'm trying to, solve this OneNote thing. Otherwise, you can drop off, no problem.
Hi,
Yes, hi,
Anand.
Dilreet. Hi, how are you?
I'm good. How are you? I don't think that you are very happy at this point.
Yeah, like I am, I am in a terrible state. Yeah.
Actually, I've used OneNote for like around a year, and I must say, like the problem you're facing, I also faced this in the initial days, and till now, I also use a kind of hack only because it's a bit irritating. So what I can tell you like what I do. Like
Mm-hmm.
when I open a new page, I create a text box.
Okay, let me actually create a new page.
Sure.
Okay, maybe I'll probably require your help even for that.
In the left side, there's a
Yeah,
notebook
I
section.
can see it. I can see it. Yes.
Just click somewhere.
Give me 1 second, please.
Sure.
Click somewhere. Um,
Like
okay.
you are using OneNote on a Mac or an iPad.
I am using it on Mac.
Okay, then
I'm not.
just like from the keyboard on the Mac, just tap somewhere. Like it always creates a text box.
It's not. I think probably it's still in like drawing mode is selected, so maybe because that's why.
Like can you double tap quickly? Like there's a double tap in Mac. Does it work?
No.
Okay, then that's like
Let me actually do one thing. Let me take up a new page once again. Actually, you know what's happening? It's by default, selecting this pen thing for me for some reason.
Okay, that is why you are facing the
Yeah, yeah,
problem.
yeah. Now I think it's fine. Now I think fine. It has. Can you see this cursor thing?
Yeah, I can now.
Yeah. So what are you saying? It should create a box.
Yeah, a small box, like a tiny box. Does it creating or not? Like every time I tap on
Yeah,
one
I
node,
think
it's creating.
it was. I think, yeah, I
Yeah, I
remember
saw
now.
when earlier you were doing it was creating a box for you.
Sorry, what?
When you were earlier trying, you were like creating a box and you said, I don't want to create a box. Like, just can you tap
Yeah,
somewhere and press enter? Just you can do one more thing. Tap somewhere and do enter on your Mac.
yeah.
Yeah, how is this a box?
Enter. Yeah, give me
Yeah,
a box.
you can stretch as much as you want.
Hmm.
Yeah, and just keep pressing enter and the width increases. So now you can just read this page inside a box and give heading, etc. Yeah, and you can keep typing or keep drawing in the box. And you can give the like and with enter you can give as much height or width that you want.
Oh, thanks. Have people dropped off?
Yes, around 30, 25 or 30 people.
Oh shit. I wish I could have I wish I would have asked you for this help earlier.
No
Now I
issues, but
feel.
yeah, this is not a really good software. I have to use it sometimes, so I do, but I don't like really like this one.
Yeah, I mean, apparently, I asked on Scalar channel, and everybody was saying that they use OneNote. So I thought this is a short thing. So I just went ahead with it. I didn't know that it's gonna give me this much trouble in the class.
It doesn't. The first one or two times you use it, always does.
Right.
And
And
like
now
you
if
can,
I how about like if I have to go back to this
yeah,
box, I'm just thinking like how do I, because this pen thing is selected right now.
yeah. Just
Okay,
click on
okay.
text
So
mode
I
and
have
it
to
will be
go
there.
to text mode.
Yeah. Like till now, like I have around 70, 80 notes, and like every time I use this text box only.
Okay. And if I save a PDF for it, will it be like okay? Let me just actually check
Yeah,
rather.
you can try it, like copy paste a line 3 or 4 times and then create a PDF.
No, this time it actually didn't. It actually scrolled the box. It didn't.
Yeah, you can increase the width of the box now as much as you want.
No, that's fine. Do you see if I'm scrolling now? It's not scrolling my writing. My writing is somehow for some reason staying here only. Can
Yeah,
you
this
see?
is weird this time. I don't know why this is happening. This is weird.
Okay.
Like I've never used this for drawing, and this is a bit weird actually. It shouldn't happen because when you're writing inside the box, it always like it's able to scroll down.
Are you aware of some good Mac-based tool which I can use?
Uh, there are a couple of them. I don't remember. I'll ping you on Slack. I know about like I at the back of my mind I can't remember, but
With
I
the
don't know.
iPad, actually, the problem is I usually use notes in my iPad. The problem
Yeah.
is that I have to mirror it on my laptop to basically show it to you guys. I can use
Yes.
Apple Notes, but I have to keep that software open in my Mac to be able to to be able to show. That is the problem.
No, but like I don't understand like what's the problem in that? Because it's a good thing. Like Apple Notes is also a good app.
Yeah, Apple Notes is good, but if you see, if I just open Apple Notes here, you can see my
Yeah.
screen, right? You
Right.
can see my Apple Notes, right? So
Yes.
if I use these Apple Notes, I don't get a writing option in my Mac. I do get a writing option in the in my iPad. So
Yeah.
whatever application that I've opened has to be opened in Mac, not in my iPad. I am basically
Okay.
mirroring my iPad, my Mac screen on my iPad, and that's how I'm writing.
Okay, got it. Okay. Yeah, then this
Yeah,
might
I'm
not be
not
happening
writing
that
on
way.
iPad and mirroring that iPad screen. Why I'm not doing that? Because if I mirror my iPad on Mac, then that's the only screen which will be visible to you guys.
Yeah, and you
I
won't be
have to
able
like
to use
otherwise
Jupyter.
every time to probably go back to Jupyter Notebook.
Yeah, that would be a problem. I get it.
Yeah, yeah,
Then
yeah.
I'll ping you the ones like, but I don't know a free one. OneNote is free, right? The ones like I explored a few months back, they were paid, not like more
I
than
don't
five.
like I don't have any problem with buying a paid thing unless like I'm very sure, as long as I'm sure that it's gonna work, I am all okay. But yeah, it should be like should be I should be able to convert it into a nice PDF, and yeah, that's all I think I would require. And it should
Yeah,
be a Mac. It should be it should run on Mac, not an iPad.
and one more thing, like earlier when we were taught at the DSA, like there were different instructors, and all of them, I guess, mostly use different softwares. So,
Oh,
like,
is it?
I guess in the scalar community, the instructor community, they know more than one softwares.
Yeah, that's what I thought, and that's how I actually got to OneNote. Somebody said that OneNote is like the go-to-go thing for all the instructors.
Yeah,
I asked.
Kshitij Mishra. He used to use OneNote, but other like Mohit, I guess, used something else, and like different instructors used. Like I never saw two instructors using the same one. I don't know for what reason.
Okay, okay, okay. So
There was
actually, the other thing with Academy is that they just have to use the notes. So what
oh
they do,
point. So
rather
yeah,
they
they will
share
be
the
using
iPad
iPad
screen.
only.
They share
Yes,
the
yes, that is true.
that is I think that is where the problem is. I Here we have to share the laptop screen because we have to show the Jupyter notebook as well, and sometimes we have to like annotate that Jupyter notebook as well as what I have been doing until now.
Yeah, like in the especially in the visualization sector, it's really useful as well.
Yeah. Now, I could have easily just done that the way I have been doing until now, because that also helps in like annotating the code, but it doesn't keep like I for probability lecture I wanted something so that I can save that as a PDF and send it to you guys for revision, because it was this topic was more theoretical. Otherwise, I would have just annotated the screen the way I'm doing it until now.
But yeah, the notes would have been useful, like for the people who don't
Right.
make the notes along the way.
Right. Let me think about it. But otherwise, like if you can just send me those names, even if they're paid, I don't mind. Matlab, that is not a problem.
Sure,
Like
I'll
I
ping you like in an hour or two. I'll send it on Slack. Sure.
okay. Thanks.
Bye.
Thanks, Ilvi. Try Evernote. I usually use Evernote, so I'll check. I was trying to actually look for Evernote, but couldn't find in my. You can take help from Kshitij. I'll take. I'll take. Today's assignment will be unlocked, but I would say maybe you can just try it a little later. Otherwise, you might not be able to do a justice. So maybe spend time in doing case study and stuff, uh, uh, and maybe just leave probability related questions. Rishabh, I can use iPad as a second screen. That's not a problem. But I now use an iPad like this to write. So here, if you can see, it's my OneNote thing. Whatever is written in my computer is showing up here as well. So I am not using iPad as a second screen anymore. I'm basically mirroring my laptop here on the iPad. Yeah, they were only, I mean, with Academy, with DSA people, it's easy because they just have to write. They don't have to like code and stuff, right? So for them, they can just share the iPad screen all the time and they can just present it. Here, if I do that, I'll have to switch to Jupyter Notebook, and that will be problematic. That's an hassle. That's a hassle. Ing to go, I'll check. I'll check. Is there anyone who wants me to unmute them if they want to ask anything? Hello. Hey, Prahlad.
Hi, Anand. Can you hear me?
Yes, Prahlad, yes.
Yeah, I had one question regarding the, like, I think in the beginning we covered about like deterministic experiment and like random experiment, right? I just like
Okay.
for the random one you mentioned like some of the example, and for the deterministic you mentioned like a couple of examples. Just wanted to like, can you just cover that like topic again and like give like couple of examples for both of them? Just a brief. I understood like a little bit of where the deterministic part is like mostly like definitive. I'm just trying
Right.
to understand and like the example where it is like completely like 100% definitive. And you also mentioned that like maybe like neural network, not to go towards that, but like just if you can touch upon that, like you mentioned neural network can be like an example of that. Like
Right.
in the neural network we use like in the sigmoid or like something like that. Right? Those are also like
Right.
we get the
So, I
probabilities.
mean, maybe uh, running a code is maybe an example of deterministic experiment. Like, let's say if you're running a for loop or like if else loop, right? That will have a deterministic output, because the code is, no matter how many times you're gonna run that code, it will have a deterministic answer, right? It will have the same answer. Correct.
Yes.
Does
Yeah.
that intention make sense to you?
Yes, I'm just trying to understand like then why would we do like I'm just trying to get an example of experiment where we would use that. Like experiment is more about like understanding like what is the logic there, right? Like I'm just trying to understand in a realistic
So,
law or experiment where we will
yeah,
have like
so
a deterministic
basically
outcome.
the point is, I think why you are getting confused is that this whole, idea of probability only arises in a non-deterministic or a random setting. So what you've been trying to do is like you're trying to think that, can you think of an example where we can probably, think in terms of probability or likelihood or whatever, where the output is deterministic, right? I guess this is what you've been trying to do, right? Now, if let's say, let me just think if there's an example which has like, just one outcome. Yeah, as I was saying, so basically you have a button, right? And if you just turn it on, the light is gonna get turned on, right?
Yes.
Right. So depending what was the experiment? The experiment was pressing the button. Pressing the button, maybe like I don't know what, downwards. Right. And that would basically turn on the light. And pressing the button, let's say upwards, would turn off the light, right? Now, think why I'm saying it deterministic. Imagine that if this would have been random, what this means is that no matter whatever you're pressing, this whole behavior is totally random. Like no matter if someday if you press down, it will either turn off the light or turn on the light. And someday if you press the button up, it will turn off or turn on. Doesn't matter. It's totally random, right? Why this is not random? Because you know that when you press this button down, the light is gonna get turned on. When you press the other way, it's gonna get turned off. Are you getting the sense, or maybe can I think of some other better example?
Yeah, I got this point. I'm just like, and you also mentioned about like ML models, right? Like, are they really like any of the models are like really like a deterministic models? Like, is it like a decision tree where like we will not get a probability?
Oh, so okay. So so when I say a neural network or a decision tree, let's say, is deterministic in nature, what I mean is that if you have a input X, all right, and if you pass it to an NN, all right, or let's say a decision tree, right, and if it says the output is, let's say, maybe class 1, maybe when you run it again on the same NN or same DT, will it give some other class or the class 1 only? Will it give class 1 or class something else?
Most probably it would be the same class. Yes.
Same class, correct? Because it
Yes.
has learned the logic and that logic remains same, right? Now it's gonna just use that logic from neural network or use those parameters or use that tree of decision trees to basically give you the output. Even if it's a neural network, let's say, and it is giving us probabilities, let's say 0.9, 0.8, and 0.7, something. Now, this is not possible, so let me make it 0.05 and 0.05. So this is a 3-class classification task. We have 0.9, 0.05, and 0.05. What I'm saying is, for a specific input X, if this is the probability, if these are the probabilities values that you're getting right now, if you run this X, if you pass this X to this same neural network again, will you get some other probabilities? No, you'll get the same probabilities. I am not saying that this model, this is non-deterministic because we are getting probabilities. Let's not think it that way. What I'm saying is, are the probabilities same or not, or are they like random? They're not random, right? They're deterministic.
Okay. So I think mostly like I'm thinking about the training part, and that you're mainly mentioning about the prediction part, right?
Correct. Okay.
Yeah.
So
Okay.
training also, like, one. See, the point is, for a specific set of parameters, be it training or testing, it will give you same output. Correct. For same set of parameters.
Yes. Yeah.
Right.
But
And if
it
you
depends
change the
on which
parameters
cycle
of
it
the
is in.
model, then it's not the same. Then it's not the system. It's not the same neural network, right? Anymore. A neural network, or let's say a model is composed of two things. One, the weights that you've learned, and the second thing is the architecture, right? It's the combination of an architecture and the weight of the model, which in combination makes a model. Correct.
Yes.
Which you say that it's the trained model, or it's the model that you finally learned, right? Until then, before learning anything, is just plainly an architecture. Correct. When you've learned the weight and when you've learned the architecture, this model is deterministic. Why this is deterministic? Because for any X, if you just run it multiple times, you'll always get the same Y. It's not that this model will start giving you some other Y, Y1, Y2, Y3, if you run it three times. Correct.
Yes. If I can ask one last question regarding the same.
Yes.
So I'm just I'm confused about the random part now. So if we toss a coin, then like it will also give like the probability will every time be like 50-50, right? Like it is also fixed. Like the probability of getting heads is 50% and probability of getting tails is 50%.
Okay.
So that's also fixed, right? Like it's not changing like until and unless we change the coin and like make it biased. Am I making sense?
See what happened? No, did you see what happened when you ran it 100 times?
Okay.
So
yeah.
Toss this coin 100 times, you will get some probability. Toss this coin 100 times again, you will get some other probability. Toss this coin 100 times again, you will get some other probability. Is it deterministic?
Okay, got it. Yeah.
We're talking about the probability, the value 0.5 we're talking about is for infinity. Is even infinity deterministic? No.
Yeah. Okay,
right.
Got it. Yeah. Yes.
Right.
Yeah, I got your point now.
Right. So,
Thank you.
We talk about probability or random stuff when we are not sure what will be the outcome. What will be the, not saying what will be the outcome, we'll say when we don't know if the outcome will be same every time we do it. We perform that experiment. If the outcome is always the same, then it's a deterministic thing. If the outcome can be different at different times on different trials, then it's a random, experiment.
Got it. So I just add one last point, like regarding the same model, like training. In the training also, if you change the data, the results will be changed. Right? Like result, like training part, like if you change the model, the parameters would be different. So in terms of that, like then the probability would be different. So then the models really be like
right. So what I said is a model is defined by two things. One is the weights, and two is its architecture. Correct. What I'm saying is this model is deterministic. All right.
Okay.
when I'm saying this model is deterministic, I am locking down the weights already. I'm saying that I have learned the model and this is the weight. All right. If there is like, other set of weights and architecture, I'll call it probably as model 2. I won't even call this as the same model.
Got it. Yeah.
If you know about neural network training, you can save different models at different epochs, right? Epoch 1, epoch 2, right? Would you call this as some other model and this as some other model, right?
Yes.
And this model will give you different results. This model will give you different results. But if you use this model multiple times, won't this give you the same results always?
Yes.
So this thing is deterministic. And what is this? This is a combination of weights and architecture.
Got it. Like I think the first sentence that you made like sums it up, right? Like even if you do it like for number of experiments, the output, if it is like defined, like it can be defined with confidence, then it is like deterministic. If not, like then it's random.
Correct.
Okay, got it. Yeah. Thank you.
Thanks. Rishabh, let me unmute you as well. Okay, Muthu, do you want me to unmute you? Okay. Muthu, do you want me to unmute you? We'll talk about John probability on Monday properly. No worries. We'll rediscuss. No worries. I'll check notability. I'll check. All right, guys. I think then I'll see you guys on Monday, and we'll discuss whatever we've discussed until now, and then we'll talk about other stuff as well. Thanks. All right. Bye bye. Thanks. And sorry for the confusion. Sorry for the mess.